Okay, here we are with set 30 question number 5. And we're asked, we're told that a 15.3 piece of steel, which contains iron and carbon, was treated with excess hot acid to form a 6.03 3 litres of hydrogen at standard temperature and pressure. And we're given an equation for this. Iron plus hot acid will make iron 2 plus and hydrogen. And we're asked to calculate the percentage steel, knowing this from these numbers. And to do that, first off, let's summarise what we know. We're going to start with mass. Our mass is going to be steel. Our mass of steel is equal to 15.3 grams. Okay, and the other thing is volume of hydrogen at STP equals 6.03 litres. Okay, well, this is very similar to our other percentage purity. We have a mixture of, steel is a mixture, it contains iron and carbon. We can figure, or if all of the iron is converted through to iron 2 and produces hydrogen, by measuring the amount of hydrogen, we can figure how much iron we have. If we then take that number of moles of iron, convert it to mass, and divide it by the mass of the steel, we can find the proportion of iron present in the steel. So let's have a look at our strategy. By the way, my strategy of writing strategy isn't something that you need to do for full marks. Okay, but I think at least in your head or by the side of your paper it is worth doing. 1. Let's find the number of moles of hydrogen. 2. Use this to find the number of moles of iron. Then what we do once we've got to here is we find for ourselves mass of iron in steel. Sorry, I'll put an extra E in there because the first one didn't come out. And then 4, lastly what we'll do, calc percentage equals actual mass iron that is present in the total mass, and of course times 100 to get that to go. Okay, and that's how to tackle these ones. Okay, now we have a strategy where we know where we're going. So let's find the number of moles of hydrogen equals 6.03 equals volume divided by molar volume, or VM I should say, which is equal 6.03 divided by 22.71. And if you crunch that through, you should get a value like 0.2655 moles. Aha! We're on track. We've sorted out our first one. Second one, let's have a look at the moles of iron. Now, the moles of iron, our equation says that we have 1 hydrogen for every 1 iron oxidized. So, number of moles of iron equals number of moles of hydrogen times coefficient of iron on the coefficient of hydrogen, which is equal to 0.26655 that we calculated before times 1 on 1. This one here, okay, goes down the bottom. Okay, this is our target. This is the thing that we're interested in. That one goes on the top. And of course, if you put that through, you don't need a calculator to tell you it's 0.2655 mole. Fantastic. We've sorted out number 2. The third part we need to do is mass. Mass of ion equals number of moles of iron times its relative molecular mass, which when you look at it is 55.85 grams is 0.26, is it 2655 times a mass of an iron atom, at least on Earth with our isotopic ratio, is 55.85. And when you do that, you should come up with about 14.8294 grams. We've got that. That's how much actual iron would be necessary to produce the hydrogen that we've observed. Now, percentage is just very straightforward. It is equal the actual amount of iron, which is 14.8294, divided by the theoretical amount of iron, which is 15.3, times 100%. And that one, if you look at it, is 96.92%. But note that this number here that we've been given is given to 3 significant figures. So giving it to 4 is kind of like inventing information that you don't have. So we need to use it to 3 significant figures. So we give 96.9%. And that's how to do those ones, and I hope that was of help to you.